All right, I want to go over completing the square a little bit more because it's a tricky method. I mean, once you get it, it's easy, obviously, but it takes a little while to get comfortable. So I'm gonna work 4 problems, I think, and then I'm gonna have you practice more with the handout. So number 1 plus 2x minus 24. Remember your first step, oops, let me turn this down a little bit. Your first step is to get the number on the other side. So I'm gonna throw the negative 24 on the right, and when I do that, it's gotta change signs. So I have x squared plus 2x, let's see, zoom in a little bit, leave some space, equals positive 24, sign change. And then the next thing, you're gonna add something squared on both sides. This is the thing that that's not part of the equation that I'm deciding to add. This is what's gonna create the perfect square. And what goes in this parenthesis is half of the middle term, including a sign. Now, sometimes if it's a weird number or an odd number, just put it over a 2. But I can take half of 2 very easily and call it a 1. And I have to put that in here as well. So what I've made here is a perfect square. And all you have to do is put it in one parenthesis squared. What goes on the inside is an x plus, and then whatever this number is, sign and all, goes there. All right, and then do this math part. So this is just gonna be 24 plus 1 is 25. So that works out pretty nice. Now you wanna take the square root of both sides because we're trying to solve for x. We wanna get rid of the squared. And a square root will cancel the squared. But you have to do it to both sides, put a plus minus on the right side in front of the square root. Don't put it on the inside. And then you get x plus 1 equals positive and negative 5. Now let's put the 1 on the other side to solve for x. So x equals, put the 1 in front of the plus minus. And remember, when you move the 1 over, you have to change sign. So it's negative 1, then the plus minus 5. Well, this means 2 things. This means negative 1 plus 5, and it means negative 1 minus 5. And we normally have 2 answers, not always, but the most common case is for your parabola to intersect the axis in 2 places. So negative 1 plus 5 is 4, and negative 1 minus 5 is negative 6. So x equals 4 and a negative 6, right? And remember, these are x-intercepts. So if I wanted to sketch the parabola, I would have an intersect at 4, or an intersect negative 6, and it looks like this. And that would be the graph. Okay, example 2. Let's do p squared plus 12p minus 54 equals 0. All right, I'm gonna move the negative 54 to the other side. So I have p squared plus 12p, leave space, equals 54 plus something. I'm gonna add plus something squared plus something squared. Now what goes in here is half the middle term. So I'm going to take half of 12, which is 6, and that's gonna go in the parentheses. So this is a perfect square. P plus the 6 squared equals Now, if you're not convinced that's a perfect square, I can show you here. P squared plus 12p. If I square the 6, I get 36. If you were to go to factor this, you could check it for a perfect square. 6p doubled is 12p. So there it is, p plus 6 squared. All right, now here I have 54 plus 36. So we're gonna do 54 and 36. So that's gonna give us 90 here. Now I'm gonna take the square root of both sides, plus, minus. The square root of the square just gives me p plus 6 equals. Now, here what you have to watch out for is if this simplifies. If it's perfect square, obviously you pull it out. But if it's not, but it simplifies, you have to simplify it. So if I take my 90 and do a factor tree, I'll get 9 times 10. You can stop if there's a perfect square or prime. 2 times 5. And so my square root is 2 times 5 times 9. Now, from the 9, I can pull out a 3, and he's gone. Can't pull out anything here. So that's going to give me 3 root 10. So I have plus or minus 3 root 10 here. Getting p alone, I have to move the 6 to the other side. And now I'm going to put it in front as negative 6, because that's one of the big mistake areas, is that people forget to change the sign moving across the equal sign. Plus minus 3 root 10. And that is my answer. Because I can't add these two together. No, my calculator, if I wanted to see what that is, remember what this, I have, just to show you here, negative 6 plus 3 root 10 and negative 6 minus 3 root 10. You don't have to do this, but I'm just showing you because down the road, hopefully we'll be able to do this. So if I take negative 6 plus 3 square root 10, I get 3.486, so 3.49. Right. And then here, if I do that, but I do the minus version, I get negative 15.49. So these would be my x-intercepts for my parabola. Okay, I'm gonna turn the page, I'm almost out of room. Example 3. Now I'm trying to pull in a couple weirder ones here, so let's see. Yeah, let's do this. 3a squared minus 6a minus 34 equals 0. All right. Now, I know I need to move the negative 34 over, but I'm noticing I've got this number here. You can't have a number in front of your x. You've got to get rid of this. I just want to have my leading term, my squared term has to have a 1 in the front and an invisible number. So to get rid of the 3, I'm going to divide every term by 3. Now I could do that after I move the negative 34 over or before, it doesn't matter, because this is going to stay 0. So those are going to cancel, and it's going to give me a squared minus 2a minus 34 thirds, we'll just leave it, equals 0. Now let's move that over. So a squared minus 2a, leave space, equals 34/3. And then we're going to add something squared, Taking half of my middle term, which is -2, half would be -1. And my perfect square becomes a, then -1 squared equals. So here I have a 34/3. If I square a -1, that's +1. So this is 1, but I'm going to write 1 as 3/3. Because if I were to get a common denominator, and I want to make the number 1 have a 3 in the bottom, I would have to multiply it by a 3/3. That's how I'm going to get 3/3. And 3/3 is 1. 34/3 plus 3 is 37/3. Not the nicest number, but we'll go with it. A minus 1 squared. Now let's take the square root of both sides, put a plus minus, and I get a minus 1 equals positive and negative square root of 37/3. Now, I haven't taught you how to rationalize denominators because of time. So, we're not going to worry about doing that. Instead, we're just going to go ahead and move the -1 over and call it a equals 1 plus or minus the square root of 37/3. And we're just going to leave the answer just like that. Because I can't simplify this at all in here. And I really can't, it's not going to reduce at all. Okay, and there we have that one. And then I want to do one more. Let's see if I can fit this on one video. I think I'm going to try. Example 4. Okay, let's do, where was the one I wanted to try? Here. 9a squared minus 21 equals 13a. So if you look at this, I want to have, normally you have everything on the left side at equals 0. I need to do some rearranging here because the a terms have to be on the left and the number has to be on the right. So he's going to get tossed that way. He's going to get tossed that way. That becomes 9a squared minus 13a, because I changed the sign. And I'm going to put equals 21. And then I didn't leave space here yet because I know that I have to get rid of this number here. Now I could have done this first, doesn't really matter when, as long as you do it before you start completing the square, you're fine. So to get rid of I'm going to divide everything by 9. So divide by 9, divide by 9, divide by 9. That's going to give me a squared minus 13/9 a, leaving space, equals 21/9. But I can simplify this. I wonder if I want to, though. I'm trying to think if it's going to be good or not. I'm going to go ahead and do it. Sometimes it's a little more work in the end, but sometimes it pays off. So I can divide both these by 3, and I get 7/3. All right, now plus something squared plus something squared. Now I have to take half of this middle number, and it's already a fraction. So remember, when you take half of it, normally you put a 2 on the bottom, but I'm multiplying by a half in this case. So it's going to be 13 negative 18ths. In other words, you're adding the 2 in the denominator with it, so that becomes 2 times 9 is 18. And then negative 13 18ths squared. So this is kind of a crazy number. A minus 13 18ths squared equals 7/3 plus a very big number, 13 squared, 169 over 18 squared, 324. Let's see here, is that gonna be, well, let's go ahead and get a common denominator and we'll see what happens. Well, over here, we'll rewrite a minus 13 18ths squared equals, okay, 324. If I multiply the top and bottom by 108, I'm gonna get, so 7 times 108, I'll get 756 over 3 times 108 is 324. What I'm doing is getting a common denominator with, I know this one looks kind of hideous, but I wanted to pick a harder one, and I did. Okay, 756 plus 169. All right, here we go. So we have 925 over 324 equals this. Now let's take the square root of both sides, plus minus. And I get a minus 13 18ths equals, now let's see if there's any perfect squares. Square root of 925, nope. And I don't think 324 is a square. Oh, it is. Oh, that's nice. Positive and negative. Okay, this has a square root of 18. Now 925 on the top, we're gonna simplify that. So I'm gonna go up here because I'm running out of room. 925, if I divide that by 25, I get, 37, and that does not break down. So that's gonna be 25 times 37. I can pull out a 5, put it in the front. So this is 5 root 37. Goodness gracious. There you go. Now, let's move the negative 13 18ths to the other side, and it becomes A equals 13 18ths plus minus 5 root 37 over 18. Boom. Now, another way you could write that would be to put it, the top over one denominator of 18. So you could write that 13 plus minus 5 root 37 over a single 18. You might see that in the book sometimes as an answer, or like the form of an answer, and just know that those mean the same thing. There you go.